All right, the Q factor, forced vibrations. There's a whole lot more to it than just these formulas, but let me explain these formulas, okay? So the Q factor, basically remember Q factor is how many times, the Q factor is how many times roughly that it's going to oscillate before it reaches equilibrium. So if this is our equilibrium, right, maybe it'll start here and go, whoa. I mean, this would be a Q factor of 1, 2, 3, 4, right? Okay. Now, the only calculation I've seen, I've never seen them use this, but I have seen them use this. So let's just look at this. The energy stored is, of course, what is it? 1/2 m omega squared x naught squared, right? Is our energy, our total energy of a system, right? So what they do is they give you a graph of the amplitude, right? And so this formula ends up being 1/2 m omega squared x naught squared, right? Divided by the difference in two successive peaks, so 1/2 m omega squared x naught squared minus 1/2 m omega squared x squared, where maybe that's the height of the second peak. So we got the height of the first peak, the height of the second peak. That's what x naught and x is. Notice that the 1/2 m omega squareds go away. You can divide those out of both terms, and you end up with the height of the first peak squared divided by the successive heights, their difference squared. No, the difference of their squares. I said that wrong. Ends up being, and then multiplied by 2 pi. Okay, that ends up being what Q is. So look at that. Never seen them use this. Okay, so let's see what happens. Maybe sometimes that happens. They'll put a formula out there, and somebody will be like, that formula isn't really a thing. This happens. Okay, just saying.